Example 2 is asking for both the volume and the surface area of this cylinder. A cylinder is a circle that is stretched into what's called a prism. A prism is just where you take any shape and you stretch it in one direction, like a piece of cheese or something. So what is the volume of this thing? Well, the volume of any prism is just going to be whatever shape it is at the end, the area of this shape, and then once you have the area, you times it by the length. So the first thing is we have to find the area. The area of the end of this is a circle, which is pi r squared. What is the radius? It's given as 4. So this is going to be 16 pi. 16 where 4 squared was 16. The units were centimeters squared. The volume of this thing is therefore going to be the area times what's called the depth. And in this case, the depth is 6, but you can see that the centimeters is knocked off the screen here. So this length here is 6. So the volume is going to be 16 pi times 6. If I were to do that in a calculator, I would find that it's 301.5928947. Of course, you're not going to write this on the exam. What you'll do is truncate it. You would cut it to 3 significant figures. Now, would that be 301 or 302? Well, this 5 kicks that 1 up to a 2. So this would be centimeters cubed, and in brackets 3SF. Now, when we're working out the surface area, we have to do this in 2 parts. To make a cylinder, what you could do is to take any sort of sheet of rectangular paper and roll it up. So the net of a cylinder is actually a rectangle that's rolled up, and on the top and on the bottom you have 2 circles. So the total surface area will be 2 circles plus 1 rectangle. Now, what are the dimensions of this rectangle? Well, the height is 6. That's the same as the height of this. But what about the length from here to here? Well, if I rolled up a piece of paper, this length is the same as the length around the circle, or the circumference. So what is the circumference of this circle? The circumference is worked out from 2 pi r. The reason I use 2 pi r is because I'm given the radius. If I plug the radius in, this whole thing becomes 8 pi. So this is the circumference around the circle. This is this length here, right? Goes all the way around the outside. And that is the same as the outside top edge of the rectangle. So this rectangle has the length 8 pi as well. So the area of the cylinder could be worked out as 2 circles, and the circle area I'll do in a moment. I'm going to leave that in brackets, plus the rectangle. Now the rectangle is going to be 6 times 8 pi, which is 48 pi. I'm going to leave it exact all the way until I get to the end. I'm not going to do any 3 significant figure stuff until I get right to the end stage. Now, what goes inside this bracket? This is the area of the circle, and the area of the circle is pi r squared. Well, r is 4, so r squared is 16. So the area of each one of these is 16 pi. So that's what I'm going to place in this pair of brackets. How many pi do I have now? Here I have 32 pi. Here I have 48 pi. Now I can group these together. Imagine this is the word pie, the thing you eat. If you've got 32 pies and 48 pies, how many pies do you have? Well, the 8 carries on to here to make 40, and then the 40s add to make 80 pi. Now, if I were to work that out in significant figures, in a calculator, this would tell me it's 251.32741223, blah, 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 blah. But we're going to write this in 3 significant figures as 251 or 252. Well, this 3 is not big enough to affect the 1, so it's going to leave it at 1. Centimeters squared to 3 significant figures.